This section of notes is about the triangle sum and the fact that triangles angles add up to 180 degrees. It's also about how do you classify your triangles, how do you name them based on their sides and their angles, and then how do you use that information to solve problems with them. The triangle sum theorem we've already been using in class, and it's something you've known from middle school. The sum of the measures of the interior angles of a triangle is 180 degrees. So the measure of angle A plus the measure of angle B plus the measure of angle C is 180 degrees. If we use that in a proof, we just say that's the triangle sum theorem. There are 3 ways of classifying triangles based on sides. You guys have been doing this since probably elementary school. A scalene triangle has no congruent sides. An isosceles triangle has 2 congruent sides. An equilateral triangle has 3 congruent sides. Classifying based on angles, an acute triangle has 3 acute angles, all angles acute. A right triangle will have 1 right angle. An obtuse triangle will have 1 obtuse angle. An equiangular triangle will have 3 congruent angles. We've already seen that if a triangle, or we talked about already, if a triangle is equilateral, then it's equiangular. I think that's in these notes. Here it says draw an isosceles acute triangle. So it has to be isosceles, it has to have 2 sides congruent, and it has to have 3 acute angles in it. Remember to mark your picture. We want to say that it's isosceles, so we should have 2 congruent angles. Then it said to draw an isosceles obtuse triangle. Just make sure one of your angles is very clearly obtuse. Again, isosceles, so 2 congruent sides. These will be my 2 congruent sides, and since we want this to be isosceles, just pick an obtuse angle measure and write that in that angle that's obtuse. I'm just putting 100 degrees in that angle there to make it clearly obtuse. Then it says an isosceles right triangle. So I'm going to draw a right triangle. We've already done construction for this before with our compass and straight edge. I'm going to draw in my right angle marking in the corner, and I'm going to mark my angles congruent here, or my sides congruent, sorry, for my isosceles right triangle. And just if it is an isosceles right triangle, then these 2 acute angles would be 45-degree angles. But we don't have to label that here. That was just something to remember. It says draw a scalene acute triangle. So to be scalene, all the sides need to be different. So I'm going to try to make sure that they look like they're different measures. And if we want to make sure that we mark them differently, like if you're not sure that they look different enough, you can go in and give them different markings to tell me, oh, these are not the same. A scalene obtuse triangle. And then we can, again, mark them different. And then label your obtuse angle with just some obtuse measurement. And then a scalene right triangle. There we go, labeling my right angle there, and again labeling my sides differently to show that they're not the same measure. The exterior angles of triangles, there is a particular formula about this. The exterior angle, an exterior angle that forms a linear pair with an interior angle. So you make these by extending one of the sides. You can see in this picture here, they've extended AC to create this exterior angle here. Forms a linear pair with the interior angle at point C there. And a corollary to a theorem is a statement that can be proven easily using the theorem itself. So we have our exterior angle theorem here. It says the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. And I've also heard that called remote interior angles. So I'm going to go with non-adjacent interior. It's the two interior angles that don't touch it. So here it's angle A and angle B that we want to add up to get the measure of angle 1. So we're going to use that rule right here. So the exterior angle is 3x minus 9, and the interior angles that are not adjacent to it are these two, 73 plus x. So we set up our equation here with our exterior equal to the sum of our two interior angles. I'm going to subtract x and start my solving here. I'm going to add 9 and divide by 2. That gives me x, but it wanted the measure of angle DCB, so we got to be careful and remember to plug it back in. So that will be 3 times 41 minus 9, which 3 times 41 is 123. Minus 9 gives you 114 degrees. So that is equal to the measure of angle DCB like we were asked for. The corollary to the triangle sum theorem states that the acute angles of a right triangle are complementary. Sorry if you hear my daughter in the background. She's having a day. So if C is 90, that means that A plus B, if you add them together, you get 90 degrees, because 180 is the total, and when you subtract the 90, you're left with 90 degrees. Here's an example about a wheelchair ramp. It says that a wheelchair ramp forms a right angle. The measure of one acute angle in the triangle is 8 times the other. So I'm going to call the small one here x, and I'm going to call the one that appears to be larger 8x. And it says find the measure of each acute angle. So since we know that 90 is used up in this corner, that leaves 90 left for the 8x plus x, those two acute angles. So 9x is 90, pretty basic sample here, x is 10. And then you get a 10-degree angle, and then 8 times 10 for the other one with 80-degree angle there.